Hello, so here we are given y is equal to cosine of x raised to the x. We want to go ahead here and find the derivative, that is the derivative of y with respect to x. Let's go ahead here and find dy dx. Well, how the heck can we do this? Well, we actually go ahead here and use logarithmic differentiation to make this easier, in a sense, for ourselves. If we go ahead and just take the log, or the natural log, of both sides, well, we get the natural log of y is going to be equal to, why do we do this? Well, we have cosine of x to the x. So taking the log of the right side, log is something to a power, the power can jump down as a coefficient. So we have the natural log of y would be equal to x times the natural log of cosine of x. And now we can go ahead and differentiate both sides with respect to x. So taking the derivative of the left side, well, the natural log of x, we know the derivative of natural log of x is 1 over x, but we have the natural log of y. So taking the derivative of the natural log of y with respect to x, we get 1 over y, but then we have to, by the chain rule, we think of this as like the natural log of blob. The derivative is 1 over the blob, but then times the derivative of the blob. So the derivative of y, well, that is the derivative of y with respect to x. That is a dy dx. We tack on here a dy dx. So 1 over y dy dx, that's the derivative of the natural log of y with respect to x, and that's going to be equal to the derivative of the right side. Now, on the right side, we have a product. We have x times the natural log of cosine of x. So we're going to have to use the product rule here, and the product rule says we take the first, so that's just going to be x times the derivative of the second. So the derivative of natural log of cosine of x, again, this is a chain rule. Natural log of blob is going to be 1 over the blob, so 1 over cosine of x, but then times the derivative of the inside piece of the blob, and the derivative of cosine, remember, is negative sine. So we get negative sine of x over cosine of x. We have x times negative sine of x over cosine of x. Okay, so that's the first times the derivative of the second, and then we do plus the second. So the second is just going to be the natural log of cosine of x, so plus the second, so natural log of cosine of x. And then, well, the first times the derivative of the second plus the second times the derivative of the first. The first here is just x, and the derivative of x with respect to x is just 1. So, well, times 1. Okay. So then we can actually go ahead and clean this up a little bit. On the left, well, we have the 1 over y dy dx still. So 1 over y dy dx is going to be equal to, well, we have x times negative sine of x over cosine of x. Now recall that sine of x over cosine of x, that's just tangent of x. Since we have negative sine over cosine, that's going to be a negative tangent of x. We have x times negative tangent of x, which we could write as negative x times tangent of x, okay? And then we just have, well, plus the natural log of cosine of x, so plus the natural log of cosine of x times 1, so we have to write the 1. Okay, so then to solve for dy dx, all we got to do is multiply both sides here by y, right? Because we go times y to the left. 1 over y times y cancels, becomes 1, and we get that dy dx is going to be equal to what? Well, it's going to be equal to y times everything here, y times everything here. So basically, the y, in a sense, is going to, I guess, distribute. And what do we get? We get y times the first piece, which is going to give us a negative xy times tangent of x, and then plus y times natural log of cosine of x. So we get plus y times the natural log of cosine of x. Okay, so there is the derivative of y with respect to x. But wait a minute, remember, we started out, we're told that y is equal to cosine of x to the x. So to get the derivative here, just in terms of x, we can actually go ahead and put that in for y. So therefore, dy dx is going to be equal to just putting in what we know y to be. So we have negative x times y. What is y? Y is cosine of x cosine of x raised to the x. That's x times y. And then we have times tangent of x. Okay, and that's going to be equal to what we have plus y times natural log of cosine of x. Again, y is cosine of x to the x. That's going to be y. And then times the natural log of cosine of x. And if we wanted to go ahead and we can actually factor out a cosine of x to the x to maybe clean it up a little bit more, and we can say that our derivative then, dy dx, is going to be equal to, pulling out the cosine of x to the x, we have cosine of x raised to the x, and then times, we could write it as, well, times the first piece. To make this a little bit, I'm going to do the second piece, I think, first. So we're going to do cosine of x to the x, and then times the natural log of cosine of x. And then we have, well, this is going to give us the second piece here. We have a negative x times tangent of x. We can pull out there, so it's going to be minus x times tangent of x. And there is our derivative completely in terms of x. So dy dx here is equal to cosine of x to the x times the natural log of cosine of x minus x tangent of x. Calculator, take care.